This is Unit 5, Day 1 and 2, Mixed Practice for functions. I'm going to do 3 sample problems from the functions mixed practice sheet. The first one I'm doing is number 4, and it says, given f of x equals 3x plus 7, find f of 5. So we know that all we're doing is basically taking this 5 and inserting it here, and therefore we're putting it into all of the x's in the equation. So f of 5 equals 3, and this would have been an x, but since we're replacing all the x's in the equation with 5's, we go like this: 3 times 5 plus 7. F of 5 equals 15 plus 7. So f of 5 equals 22. Now basically this is saying that when the input is 5, the output is 22. So we could always write our answer like this as a point, as a solution set, 5, 22, because x equals 5 and y equals 22. But this is what you'll write on your answer sheet. Okay, the next problem is part of problem number 8, and it says complete the table. You'll notice that I only have 3 numbers, you have 5, so you can go ahead and do the last 2 on your own. Now, given the function f of x equals negative 5x, we need to complete the table. So our input is the x. So for the first one, our input is negative 9. So basically what we're going to think is f of negative 9 equals negative 5 times negative 9. Negative 5 times negative 9 is going to be a positive 45. So that's what you'll put in your table. Same thing for the next one. F of 7 equals negative 5 times 7, because we're just replacing that x in the equation with a 7. So our answer here would be negative 35. And then the last one, f of 8 equals negative 5 times 8. Again, just replacing the x with the 8. Negative 5 times 8. Oh, I messed up. It should be negative 8. Negative 5 times negative 8 is a positive 40. The last problem is the first one under number 9, and it says, which of the following represent functions? Write yes or no on the line below. So this is just a sample. We have the domain, which is really another way of saying these are the x's and these are the y's, okay? Or this is the, that's the x and this is the f of x. Okay, let's get rid of this. That would be the x that you would insert, okay? So, for every input we can only have one output, and that makes it a function. So for the first one, 2 is the input. Let's write that underneath here. Input. And this one is the output over here. And that's why we have the lines between them. So 2, if you input 2 into the equation, which we don't know what it is, into the function, you get a 4. If you put it in a negative 8, you get a 0. If you put in a 1, you get a 5, and if you put in a 3, you get a 1. So what I'm most concerned about is that all of these x's right here have only one y to go to, okay? And that nothing overlaps. We don't want to have, your input of x, being, let's say we had a 2 here on this side, and then we had another 2, and the output was a different number, not 4. So it was like 5. Okay, then this means because we have 2 of the same right there, 2 and 2, and the the range is different, our output is a different number, that means that it would not be able to be a function. But obviously, this isn't in the problem. Okay, I just did that just to show you. So the way it is right now, with the 4 numbers for the domain and 4 for the range, you would write yes. Yes, this is a function.